Hello? Are we live? I think we are. Are we here? Cheers. Who knows? Oh, and we got liftoff. Okay, great. Wow, what a mess. Hey everyone. Hi. Hello Peter. Low volume here. Interesting. How's that? Volume is very low. What is going on? So, I'm on a new version. You're competing my attention with the boys on Amazon. I don't know what that means. Okay, so I'm using a new version of OBS. Okay, just hold on folks. Filters, properties, filter. I need some way of boosting it. How do I, gain? Okay. How's that? Are we a bit better now? Turn up my mic. There's no volume on my mic. Just, hey everyone, very muddy pick. Really? Looks sharp for me. How about if I, okay, so just let's solve one thing at a time. Oh, the boys, right? Okay. A little better. Hang on. How's that? Is that even better again? Hey Chris. A little hum. That could be my heater. Is it? Okay, hang on. Properties. See if I can get the microphone a bit closer. Hey Peter. So that's better? Oh, hey Sam, thank you. I was saying, awesome. Yeah, I'm a bit over my PlayStation days, but thank you. You need an lapel mic. No, I've got a brand new Rode mic, and it was great last week. So, just to explain to everyone, I'm on a new version of OBS, which has destroyed all of my settings, and you can see that my chat looks different on the stream. So after last week's stream, I spent like days researching stuff, and I almost started modding my own version of OBS. How do I wake up so early? Me, I've been up, I could have started the stream an hour ago. I probably should have. They're good mics. My daughter has one. Yeah, it's a really good mic. It's top chat, and I can't change the chat, so please don't ask me. For everyone that's going to remind me. So the sound's better now? Good. Okay, the sound's better. Great. Okay. For everyone's going to keep telling me, I can't change the chat. So here's what I found out. What's potato cam mean? Please explain the difference between MicroPython and Python. Yeah, can you just hold that question? Ask me again in a few minutes, or someone else will answer. Did not decide. I was looking into doing that instead. Yeah. Well, okay. So here's the thing, and I only found this out last week after the stream. On a Mac, there's some limitations on OBS on the Mac. Of course, because it's the Mac and whatever, and everyone, yeah, Apple, blah, blah, whatever. So, on the Mac, OBS, when it captures a window, so like if I have the chat window up, like I've always been done in the past, and I bring that window onto my OBS screen, it uses 100% of one core on my machine. I've got an 8-core machine. 8 core? 6 core? What have I got? maybe it's a 6, I got a 6-core machine, sorry, 6-core, I got a 6-core i9, and it uses one whole core 100%. But if I do it as a browser window, like I've done now, then it takes 5%, right? So that's why OBS runs like a dog, because if I capture a window and I capture a window and I lay all my windows out, every one of those windows takes one core and 100%. Refresh your browser if you're only on 480. Hey Brian. The stream started off with bad health, but it says it's good health now. So just try refreshing your browser. So unfortunately, if I set up the chat like this as a browser window, not as a window capture of another window, I can't interact with it. I can't click in it and change top chat. I can't even change my skin from dark skin to light skin, because it's just a URL it's pumping into this thing, right? So I have no control over this chat window now, unfortunately. The good news is OBS is taking like 60% of one core right now instead of 200 or 300%. It was triggering constant redraws. What was? I didn't, Yeah, so when it does a screen capture, when it captures another window and places it on, it absolutely kills the CPU. So I'm stuck doing this now. So the video looks like a painting. What's if I change? Okay, so what about this camera? Look at that. Whoa. Different camera. You mean just the coloring? This coloring is also bad. This camera is better? Okay, it just means I can't look at you now. That's all. Okay, that's fine. We'll go with this camera. So hi everyone. It's not the camera. On-screen chat is just... It's not the cam. On-screen chat is just readable. Yeah, look, it's not... This whole setup is not great, and unfortunately... Now I'm glowing, yeah, and I don't even have... Look, I've got autofocus on, so it's going to go in and out of focus. But what can I tell you? Yeah, there's a white balance issue on it, and I can't seem to fix it. It's really... It's been a very frustrating week trying to reset OBS up. But there are so many bug fixes in this version of OBS that I kind of had to give it a shot. And it is asking again. Okay. The difference between MicroPython and Python is not much. MicroPython is designed to run on a microcontroller, and Python is designed to run on a computer. Other than that, MicroPython is very, very close to just regular Python, or what's known as C Python. There's obviously a few things that you can't do on a microcontroller, and some things are not overly performant, so you don't get the entire Python framework. Otherwise, it's pretty much syntactically the same, with a few caveats. Obviously, on a desktop with normal Python, you don't have access to low-level hardware, where on the MicroPython you do. The old days you had to be happy with 300 BPS modems. Exactly, right. Remember those days? I remember those days. Interesting, so it's not going to let me... let's see if it lets me change the... Oh, it is letting me change my camera. Let's see if I can adjust the white balance a bit. Whoa. Maybe, not really. Sorry, I'm trying to fix my camera. The commands, yeah, the syntax is pretty much the same. There are obviously some things you can't do on a microcontroller. There's a lot of libraries in Python that just won't work. Oh, Johnny, I saw your chat before. We'll get into that. No, I didn't, and I'm not touching Catalina for a while because it's a stack of stuff that doesn't work, and you should have done your research first. Let me just... Okay. Get one of those professional video editing panels instead of using your crapple. Ooh, my crapple. That's not nice. I remember when I used to, Peter, no, Ian, I used to, like, I had I can't remember what it was called. It was, yeah, you know, where you could actually see the text going across the screen when you were coding. Like that's how slow it was. Anyway, whatever. Hi everyone. Welcome. Wow. I wasn't even sure that I was going to get the stream up and running today, but so far so good. So I've set up some different desktops. Hopefully they'll work. I've got that view. Look at that. There's a dot. Yay, a dot. It's not supposed to be a dot, but there's a dot. This is just I've got a filter here just in case we want to filter it. And yes, the chat is gone funny now. Oh, great. Let's move it over there. I'll make me smaller. There we go. So I'm still rearranging all this. I can't believe when I upgraded OBS, it completely destroyed everything that I had set up. And then I've got this capture, which has also got my desktop, and hopefully you'll be able to see that. And none of these are using a window capture, which means this should all be performant, hopefully. Okay, bye, Id. Thanks for popping past. Brian's very beady. I just shaved mine off. I need to lift the camera up a fraction. Yeah, maybe not. So I'm not going to do a roll call because there's too many people. Hi, everyone. I left it too late. And yeah, there's over 70 people in the chat now. So yeah. Hi, everyone. It's been a ripper of a week. Has everyone had a good week? Yeah. So Mac OS Catalina is out, which is a pretty great update, but there's just, OBS doesn't work in it. So I've updated my Mac Mini over there. But yeah, just to try it out and to see what doesn't work. And OBS won't even boot, it just insta crash. Do we need a chat window visible? Yeah, well, it's interesting. We probably don't, because you can see the chat in the stream. But the couple of times where I didn't have it, or in StreamYard when we didn't have it, a few people complained that it wasn't on there. So yeah, I don't know. Do we need a chat window? Maybe I'll stop doing a chat window. But it's nice to have everyone here. Oh, what was I saying? No, Catalina. God, see, I've distracted. Now, who distracted me? Someone distracted me. I don't know. I'll blame Crowley. There's no Crowley yet, but I'll blame Crowley. OBS essentially needs a dedicated appliance machine that's set up once, never updated, touched. Yeah, I mean, my previous version of OBS, apart from the dying at near the end of my stream a few times, was actually really okay. Yeah, Catalina 64-bit only, but they've been warning you for a long time. So Mojave they've been telling you for ages that every time you put a 32-bit app on your machine that it was going to get the boot, and even High Sierra, they've been telling you that. So it's been 2.5, almost 3 years that they've been warning everyone to, excuse me, move away from 32-bit apps. So if you didn't know, well, but yeah, there's a few things that just aren't working right now. The Arduino IDE is a bit of a problem. OBS is a bit of a problem. But there's also a lot of other stuff that works really well, and it's more performant and better. Need chat for playback. Only need chat for playback. No, because the chat real-time playbacks in YouTube. So I make sure that that's enabled. So if you watch the video, if you watch the stream back later, the actual chat window, unless you go full screen, you can't see the chat window. The actual chat window updates in real time. It's pretty cool. Who needs Arduino IDE either way? Yeah, well, when I say that, I'm also talking about Platform IO. I think some of it is hooked, I believe. It's nice to know how far behind the stream is lagging to know what the current chat... Yeah, possibly. I don't know. I mean, it takes up screen space, but otherwise you're just going to see my bigger head, right? So does it, who wants that? What about, what was that? Reboots and needed watchdogs when using MicroPython. Is it easier to create crash-free code than Arduino C? It is. I believe it's easier to create crash-free code than in Arduino, because you can't do as many stupid things as you can in Arduino. When I say, or in C, and when I say stupid things, that they're just, you can just, not even from a watchdog point of view or an interrupts point of view, although managing them all and dealing with interrupts and everything and the hardware in MicroPython is way easier than doing it in C. But yeah, just the fact that you can bring down any micro with some bad memory management in C is just really, yeah. And that's what a lot of people do, beginners who don't really understand what they're doing with C, and they just grab libraries from everywhere and they don't even look inside the libraries to see how good they are. And there's just some really badly written libraries for the Arduino environment. So yeah, Memory management's normally the killer, as Adam says. No, I can't make the chat dark, Brian. You missed all that. This is using a browser link, not a window capture. I can't interact with it. I can't click in it and change the top chat to live chat, and I can't make it dark. My actual chat next to me that I'm reading properly, because that chat's too small for me, is dark. So what you're seeing on screen is OBS capturing a URL, and because it's capturing a URL, what? No way. Okay, hang on. So can you also, I heard it. Okay, can you also find how I can change it to live instead of top chat? I spent about 20 minutes before I started the stream. Garbage collection takes down so many higher level environments. I don't agree on that, Peter. Yes, in some environments, yes. Like, you know, when you're building a game engine and you got garbage collection, that's a problem. Garbage collection on a micro, no micros have enough memory to have that much of a problem with garbage collection, right? I don't believe, you know, and if you need super high performance, like if garbage collection becomes a problem for you, then you shouldn't be developing, like you should be developing in C, but not in the Arduino environment. You should be developing like, so the thing with the Arduino environment is you're developing with an abstracted layer. So like let's talk about the ESP32, right? Specifically to the ESP32, you're accessing the IDF, but you're doing it through a HAL, and you're doing it through a wrapper, and so you're just layering on layering, right? You're calling a function that calls a function, you know, and that's not performant. You get missed cache hits and stuff when you're constantly calling functions. Like if you've got a loop in Arduino, and inside that you're calling an IDF function, you're calling it a function from the expressive wrapper and HAL that then calls a function inside the IDF, and you're doing that every wrapper, and you're doing that every frame. I'm used to gaming. You're doing that every loop, right? Then you're going to get missed cache hits and all sorts of stuff, right? That's not performant either. I think that you just got to pick and choose what you're. Hang on, let me just change this. See if I can change the to dark. Whoa! Thank you, Brian. Okay, that is cool. Sources, does the menu show interact? What? When you right click on the browser source, does the menu show interact above filter? No, you can't. I can't click on this right. What do you mean interact? It's not a. That's a. Oh, interact. What? What is this? Interacting with chat direct. How do I... What does that do? Oh. Okay. No way. Okay, I can't click on the top chat thing, but I seem to be able to click on... Oh, hang on. The window... The mouse is not in the right spot. Oh, that's funny. The mouse is offset. Maybe I can. Hang on. Oh, bad stream. No. What does RMT mean in the ESP environment? If you got the horsepower to spare. Okay, that didn't kind of work. But I got dark. Thank you, Brian. Remote. Okay, so RMT is a way of... it was designed for, basically for IR, for things like remote controls. It's a way of, at a very hardware level, assembling a whole bunch of bits and just pushing those bits out through hardware, bypassing interrupts or anything else. It's not like you're streaming the bits out through an I/O, right? Like you do, you know, like in the NeoPixel driver or something else, you know, where you're going through and you're saying, okay, your I/O, make it high now, make it low now, make it high now, make it low, you know, that type of stuff, where you got timing. This thing is designed, you just build a whole bunch of bits that indicate, and I'll show you through a logic probe today, and it just spams it out through a channel. It's like DMA, right, for IR. Hey, Mike. And so it's something, I don't know, like it's unique to the ESP32 in terms of the microcontroller space. I mean, I'm sure it's not only, like, I'm sure there's plenty of other technology that has stuff like this, but I don't know of any other micros off the top of my head that actually have this, or at least implemented like this. And so, yeah, it's really good. It's a way of guaranteeing delivery really fast of a whole chunk of bits. And it's perfect for pixels. And, wow. So my stream says it's really bad. I'm not dropping frames, but I don't know. There could be some internet. There was internet problems around here last night, so I apologize in advance. It's something like interrupts. No, nothing like interrupts. No, it's just it's a low level. It's a way of you pushing data through an I/O at a really low level in a guaranteed delivery. You're not pushing it one bit at a time. You're not saying, okay, if you've got a string of, let's say, 1,000 bits, you're not saying, okay, start sending them, and it goes bit, 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 bit. It grabs that 1,000 bits and it goes bang, and it's guaranteed delivery through the hardware based on the timing you give it. And I'll show you in a moment. I'll do it on the logic probe. You'll get to see what I'm doing on the display. Well, and now it's hot in here. Whew. Okay, heater's off. And we've got the spinning wheel and 1440p. Yeah, I think just refresh your browser. I don't know if it's on my end. Oh, who knows? Who knows? So, okay. I'm trying to think, is there any news I need to catch up with? I need to find some time to play with those funky 3-cent microcontrollers. They sound like fun. Yeah, I mean, it does sound like fun, but who's got time? I don't have time to... I mean, there's so many things I want to play with. Like, so... I don't know if you can even see. Oh, okay. So... My desk setup is still very bad in terms of coverage of cameras. So I'm just going to do this for a moment. Sorry, folks. So you see this here? This is my DS Logic. Well, it will focus. Hopefully. Focus. Focus. Oh, now it's not going to focus. Oh, there we go. This is my DS Logic. It's a logic probe. And I bought this when I was trying to debunk my my PS RAM issues on the Tiny Pico, but then by the time it turned up, it took like, and actually I went to China and came back, and then it was here. So like it took weeks and weeks to get here, and I'd solved it. So it's been sitting on my shelf unused until yesterday. Don't even know how to use it properly, but I'm going to show you me using it to work out how to find out what's going on here. Okay, there you go with the camera. I'm just going to put it back. Hopefully. Kind of in the right spot. Are you using APA.star with NeoPixel libraries? No, I'm not. I'm using I'm using my own libraries for both my NeoPixel stuff and my .star stuff. I was using Adafruit's NeoPixel library like for my 7-segment displays and stuff, but at least I've written my own code for the ESP32. So like my libraries now, at least for the X7 displays, which are these ones, they're now using, on the ESP32, they're using my RMT implementation in Arduino land. So if you plug an ESP32 into it, it directly understands that it's that and it does RMT. Otherwise, it falls back to the NeoPixel library. And in MicroPython, I'm using, obviously, my own libraries. Sorry, there was a bunch of questions went past before. What did I miss? Okay. Ask again if I've missed anything. Crotch cam for the second. What? Did you see a crotch? Oh, sorry about the crotch cam. Oh well. Whoops. No worries, Jim. Now there's greetings from the opposite side of the world. Austria. Hello, Dieter. Okay, so, wow. Trying to think if there's any other news. I don't know. I feel like I've done nothing this week, but I haven't. Did everyone catch MakerCast? How cool was MakerCast? Hey, Alan. We had Jerry on the Jerry Ellsworth on the MakerCast, as well as obviously some makers, some of us. Hey, Philippe. Wow, so many people, so many new people today. Excellent. Unexpected mailbag. No, I've got no mail. Well, actually, no, I don't have any mail to open. I don't. Well, I've got some stuff, but I don't really want to show you yet because it's, let's see if I can hide this. because yeah, it's for a project, and I don't want to give it away. I don't know. But yeah, MakerCast was excellent. I'll have another coffee, Alan. Thanks. Mine's already, half gone. So thanks. And Munich. So I started, so for those that noticed, my stream time was different today. Did you see it? Andy saw it. Wow. That didn't last long, did it? I've got to, look at that. See everything through a lens. Oh, dreamy. How cool does that look? Anyway, I've got myself a Fresnel, Encino, a Fresnel lens. I got myself actually quite a few of them. I might have a pile of these for something that I'm playing with. You never know, and it may work and it may not. I may even never finish it. Who knows? But I took it out because I wanted to see. Actually, I'll leave it out now that you've seen it. I want to see what happens if I put it over the display later. I want to see what happens to the pixels, that's all. But that's not what it's for. But I just want to see. Fresnel or Fresnel. Yeah, it's Fresnel. The guy's name was Fresnel. But everyone calls it a Fresnel lens. So, you know. I'm okay being wrong. I mean, apparently, you know. So when I did my first ESP32 S2 video, hey, look, it's the S2 chip. And I said cache instead of cache. Oh my, I got slammed in the chat. For those of you that haven't seen it or haven't read the chat, just go back to that video and go read the chat. I got slapped. Slapped by so many people because I said cache instead of cache. Because apparently it's pronounced cache, right? Like cache, yay. Not cache, because there's no AI in it. But you know what? I've called it cache my whole life, and I've everyone I know who's ever said the word has said cache, right? But apparently it's cache, and anyway, I got slapped. So let's call it a Fresnel lens, so that way people are going to come on my chat and slap me again, because you know, I love it when people come to my YouTube channel and tell me I don't know what I'm talking about. It's awesome. My wallet is empty already. Yes, and it's the no cache. And it's usually cache, yeah. It is, I know it's cache. But it's, I don't know, I don't even think it's an Australian thing. No, I've heard some Americans call it cache. I've heard it, anyway, it doesn't matter. Someone is wrong on the internet. I'm the only one wrong on the internet. That's okay. That's okay. I just like it how they'll come and they'll not comment about anything else on the video, but just that. Aluminium. It's aluminium. Look how it's spelled. Whatever. Oh boy, here we go. We're going down a rabbit hole here. Hi to anyone that's just joined. Hello. Okay, so let's get started. So what's this all about? You know nothing. Unexpected make us snow. I do know nothing. I admit I know nothing. That's okay. If I knew everything, what would I do if I knew everything? Wow. I don't even know. It's never going to happen, so who cares? Color catalogue of my favourite homeopathic analog computerized aluminium aeroplane immobilizer. What was that? Hey, DC Allen. Let's do tech. Okay, let's do some tech. Yes, let's do this. Because I don't know what else I can tell you. I've got new boards on the way being made. I'll show you those when they get here. And so, what happened? So, it's definitely, can I tell you, it's GIF. It's GIF, it's not GIF. The guy that invented it has no idea what he's talking about. It's GIF. Cure every nasty disease. Okay, what you do if you knew everything? You would know what you... Yeah, maybe. If I knew everything, I'd know what I would... That's a very good point, Ian. That's really clever. Wow, okay. Just a quick warning now. Sorry, I'm just this whole chat's derailed. Ollie's going to camp today, so I just want to do a shout out to Ollie, to school camp, saying, hey, have a great time, Ollie. Have a great time, Ollie. But also, At some point during the stream today, I'm going to do an intermission where you can all go have a toilet break. I'm just talking to the camera now. Have a toilet break or get a coffee or whatever else, and I'm going to actually go give her a hug before she leaves, because she's going for 3 days, and I'm streaming, so I'm going to miss her going. So that's all. Ellen's saying, Sion, the Royal Society add an extra I to aluminium to make it sound better. GIF peanut butter. It's graphics, not Jaffics. That's really funny. That's right. And it's GIF, not GIF. GIF is a cleaning stuff. GIF is cleaning product. Like, does everyone have... Anyway, I haven't heard of GIF peanut butter, though. Is there such thing as a brand? Not in Australia. We don't have that. But we have GIF cleaning product. But it's with a J. Oh, Alan's giving me a coffee. Thank you. I can smell it from here. Hey, Renee. Okay, here we go. So, I mentioned a while ago that I just mentioned again now, that I'd made an RMT driver for ESP32 for the Arduino side. Ugh. But on the MicroPython side, I've been kind of waiting for that, and because it needed to be implemented, it wasn't like it's obviously in the IDF, but it hadn't been exposed to MicroPython. So Matt Trentini did some work on that. That just reminds me, hold the phone. Hold the phone. Just 1 second. Okay, sorry. I reminded myself I had to send a message. Sorry about that. So, Matt Trentini finally found some time, and he put together a pull request with RMT implemented, and I've been testing it out, and I've been having a hell of a time getting it working. And it some of it was we had to adjust some code, and some of it is just understanding the timing, because so it turns out that with NeoPixels, we'll call them NeoPixels, but they're not, like WS2812. Hi Yazzie. I'm not ordering pizza. I didn't order pizza. Pizza at 7:30 in the morning. Like, maybe I did an Uber order for coffee, more coffee. So apparently with SK6812s, WS2812Bs, all the different versions, whatever they are, their timing on them it's really loose. Like, it's all these data sheets, and they're terrible, right? But at the end of the day, there's a guy called Josh.com, who has done a lot of research into them, and he's worked out the range of timing that you can use to talk to these pixels. And so it's been kind of difficult to get timing right to actually get them to do something, but I have. So what I'm going to do is I'm going to show you what I've done. I've got more work to do on it. I've done it all in MicroPython. I'm sorry, this is not going to be necessarily a coding stream, okay? Uh-oh, because I have so many fans, I have a special request. I already did a shout out to Ollie, but Yaz, and I think a few people said have a good camp, but if that's what you're going to do it again. Go for it, Yaz. What does Brian mean? I don't know, what does Brian mean? Numbers, would buy your 7 numbers in Tindy, but I'm in soldered form. Is that possible? Hey Dita, which ones are you talking about? Are you talking about these new ones I'm making, or are you talking about my old ones? My old ones were available assembled or not assembled, but I've sold out. I've got none left. I sold my last two. How exciting! I've sold my last two Neo segment displays last week. Oh, he just needs to print something. Hang on. Okay. Go for it, Yaz. Print away, and then you can come in and say hi. Or not. Seen that video where he taps a logic analyzer at multiple pixels and watches how the data is retransmitted. Yeah, I'm not looking... Yeah, the retransmission stuff, that's interesting. Getting the transmission right to start with, that's the hard one. The new ones assembled. The new ones will only come assembled. They won't come as kits, because they're too hard to assemble. The new ones are they're surface mount only, just like the other ones are, but they're really tiny with really tiny pads. They can't be hand soldered. They need to be reflowed, and if you reflow them with hot air, you'll melt them, because they're just all plastic. So yeah, they're coming pre-assembled. You'll only be able to get them that way. If I ever release them, because I just struggling for time. My laser printer can cloud print over the internet. Oh, Yas can print over from wherever she is. That's fine. She's asking me because I'm streaming. She didn't want to make the noise of the printer happening, that's all. I made your day. Cool, I'm glad I made your day. I just got to release them. The page is ready to go. I just have to do a video. That's why I'm trying to get the last bit of driver running. So let's switch camera views to, let's go to here. Now I'm going to just, give me a second. I'm going to see if I can make my font much bigger so you can read it. It's also off the edge of the screen. And so is that readable, or do I need to make it bigger again? Everyone let me know. I'm out of toner. Can I print some bits too? Yeah, no. Sorry, Paul. I want some pick and place goodness. Today? Not happening today. Hey, James. Stuck at work. Oh, no. Doing crunch. Can everyone read this? Or is it not big enough? Is this the Ortrix case? I don't know what that is. Enhance, click, 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 enhance, click, click, click. What are we doing? Is it just right? Okay, well, if you're on your phone, I'm not sure I can help you with the phone. Okay, as long as you can kind of read it. Let me go one bigger. Okay, that's for... Okay, anyway, it just makes it hard to scroll through the code when it's so big. So... is this using, hang on one second. Right. So I've got, let me start off with some other code. I've got too many things open here. See, now my window is too big. And now I can't find it. Okay. I have to get my files this way. Single row. Okay, so I've got some code here that pretty much mimics what you see in the demos of the 226 problems. I don't know what that means. That mimics what you see, like it uses a color wheel, like a MicroPython, my MicroPython implementation basically of just the color wheel. It's not using this one at the moment, that's fine. And it basically goes through and just fills that display with color. So I'm just going to do that now. So I think I've already got it on here. So I'm going to go into my REPL and I'm going to type import RMT, I think single row. And as you can see now, I've got a single row of pixels. Is that better? There we go. Let me just go bigger. So can everyone see that? Single row of pixels. Yay. It just fits on the screen. That's without. Whoa. And that's with. Now that took me 2 days. 2 days to get working. What did I miss? And keep on piling by starting more campaigns. Yeah, by the way, for those that don't know, Peter has just announced his new campaign on crowd supply for the Glasgow board. I'll let Peter post a link to it. Can you post a link to it, Peter? It's a massively advanced board. Yeah, and it sounds really cool. I don't know what I'd ever do with it, so I'm probably not going to get one. Sorry, Peter. But yeah, it's pretty nuts. Make the lights blink in sequence. Well, let's just start with pixel 0 is orange. Yeah, no, so they're changing color. It's not orange. It's red going to pink because it's just using a color cycle, right? So if I just go back to here, you can see that these are all the different pixels, right? So it starts off 25500, then it goes to, it's just going through a color wheel. Okay, I can make that a bit clearer by, hang on, let me just go. Interesting. I'll make this +5, plus equals 5 on the rainbow, so it'll change color quicker. Just copying it over. Import. I should have used smaller names. Single row. And there we go. Okay, so now you can see it's cycling through the color faster. So it's going from red to blue. It's just that the camera can't pick it up. That's going red, more red, pink, 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 lighter pink to across to blue. Yeah? Does that make sense? Okay, let's see what the Fresnel, see, let's see what the Fresnel, what that does to it. Not a lot. Yeah, not a lot. Oh well, there you go. Yeah, the board, the Glasgow does look amazing, absolutely. It's just, yeah, I don't know what I'd do with one, honestly. But yeah. So, okay. Yes, the color wheel is terrible. I mean, even Adafruit have moved away from their color wheel. If you look at their latest NeoPixel libraries, they're not using their color wheel thing anymore, which, by the way, the color wheel code that Adafruit uses and a lot of people uses was actually written by Damien George, who invented MicroPython. Just a bit of tidbitty stuff there. And so one of the things I've been doing is moving away from that and moving to using HSV color space, which gives you a much better transition of colors, which what this is, so if I just go import RMT test 3, I think it is, and I can't spell import, RMT, oh, wrong screen, RMT test 3, oh no, what have I done? That's not my test 3 code. Oh, hang on a second. Okay, I was mucking around with this last night. I probably shouldn't have been. Pixels 175. Okay, try that again. Byboard. Import test RMT test 3. So RMT test. I'll explain what all this is happening later. Okay, does it clear? There we go. So as you can see now, it's a much nicer transition of color. I need to stream a bit using the Glasgow. I'm sure I will. Like I'm sure I could, if I understood it better. Like reading the specs of the Glasgow, it's like, whoa, that sounds insane. Where am I ever going to use that? So you can see the color transitions here is much better, right? I'm just cycling through some different colors. The LED phosphor doesn't interact very nicely with the camera filter. No, I mean, pixels on camera look terrible. Maybe I can dull the camera down so it can look a bit better. Maybe I can do it without the lens. No. Without the filter. There you go. I'll just go darker. It gives you a better indication. Yeah, so a lot of the light, yeah, so fast LED you can use HSV. Adafruit have now moved their NeoPixel driver over to HSV as well. Hello, Mr. Watts. Oi, oi. But none of this really exists in the MicroPython space, so that's what I'm working on right now. For me, the one thing holding me back from, you know, launching these is I want to have MicroPython drivers for it, for those that want to use it. And to do that, I needed RMT, which is what I've been waiting for. So I finally got RMT. So this is now displaying using RMT with MicroPython. And and it's working pretty well. Like it's, as you can see, I mean, it looks kind of nice, right? So, but what I wanted to do is have a look at the data and speak about the data, right? Because this is what was interesting for me, because the timing and the way the data works. So does everyone? Okay, that's a silly question. I'll start that bit again. Has anyone here looked at the data, like the way you send data to like a NeoPixel? We'll call it a NeoPixel, right? It just groups everything together. Can't figure out the top chat versus chat. Yeah, neither could I, Brian. Thank you for looking, though. I appreciate it. What update rate can I get? I have no idea. I haven't gone that far yet, because right now I'm also spamming stuff to the screen, as you can see here, to the output, which really slows things down. Because what I'm looking at is what the color value is, right? And now there's a problem with this, and this is what I want to work out. I'm going to see if I can work it out on the stream today, and maybe some of you smarter people than me will be able to help me with this, because there's some stuff that's not making sense. But so with the, yeah, as you can see here, like I've got a rainbow. That's my variable. It's up to cycle 13711. It goes all the way up to 653 something, whatever the value is, and it loops, which is fine. These are the values it's sending. So it's GRB. Right, we've got to remember, although this value is RGB, but the order of the colors on the pixels are green, then red, then blue. Yeah, the timing diagrams are terrible on the data sheets. They're very specific what they tell you, but it turns out the timing is way looser than what the data sheet says. Like dramatically different to what the data sheets say. So that's been a bit of a challenge. And then what I'm doing, I'm just showing those values in binary, but I'm just showing them. These are just the least significant bits, right? So like 0 is just showing a 0. It's not showing 0, 0, 0, 0, 0. But these are 8 bits. Actually, I wonder if I could probably show them as. Am I showing the bit? Interesting. Maybe I can show this as I don't know if let me see if I can format this so it's easier to understand. 7 nanoseconds typical. So the data sheets tell you that it's supposed to be 0.8 microsecond. Do I have a data sheet? Let me see if I can find a data sheet that I can show you. We'll have a. It's quite interesting. Well, I think it is. I can just grab it. Okay. I've actually enjoyed this because it's like, obviously I'm writing some software, but I've had to go down to the hardware level and look at timings, right? So this is Josh.com, and so he actually set up a system where he's got I don't know how many, like he's got over 1,000 pixels in a string he's driving, and so timing for him was critical, right? And he's got them updating at 30 frames a second. And so the data sheet by default, let me see if I can get this bigger as well. So the data sheet, so the way it works is you send all the colors. So you got 3 colors, or in the case of my display here, these are GRBW, so it's 4 colors I need to send, right? Because I need to send the white component as well. So so what you do is you send each color in a row using high and low for each bit. And so you do a high bit, you do here a high and then a low, and the timing of the high and the low dictates the color bit, and then you do a high and a low for the off state. So low doesn't mean off, like 0, and high means high. Both of them have a high and a low state, and depending on the length of your timing, it knows it's a high or a low. So every signal you send, whether it's a high or a low, to say there is a bit here or there's not a bit here, both of them have a high and a low state in the signal, which is kind of confusing, but it does that so it knows color, 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 color. It never has to guess, is this a longer low state than this one, to say, is that an off or an on? Does that make sense? So every bit that you send has a high and a low, but the timing of them is critical to decide whether it's going to be an on or an off. I hope that makes sense. Oh, I'm missing the chat. You can, yeah, and timing is even looser, yeah, with this thing, or the lower the less pixels there are. Use this for live chat instead of top chat. How? Oh, hang on a second. Leo just found something. 1 second. I'm going to try this. Pop out 1. Dark theme 1. That's what I'm using. Leo? Sorry, that doesn't change anything. Yeah, I'm using live chat, not top chat, in the URL. So yeah, that's still showing up as top chat, unfortunately. Oh, hey Rob. Yes, it's pulse width coding, but it makes it kind of really hard to read the data, right? Because when you look at the data, just like in a plotted graph, it's not obvious, right? You can't see where the on and off bits are. And then what makes it even more confusing is, depending on the bits that you're sending, based on the colors that you're sending, top cat, it makes it even harder to understand visually what you're seeing. Like, it's really hard to read it. You can't, like, you know, for a normal, if you're looking at a scope or a logic analyzer for just normal high and low states of stuff, it's really easy to look at the highs and the lows, but in this case it's really hard to decipher. And so yeah, I pulled out the DS logic, and let's just quickly go back to this. So this is the normal timings. Well, they're actually not. It says here these are the official timings for the WS2812, but they're not, because I've got two other data sheets that have different timings for this. The data sheets say 0.4 microseconds, 0.8, 0.8, and 0.45 here. But the data sheet he found has 0.35, 0.7, 0.8, 0.6. Hey, keep it nice, Marin. Who's expelled from my class? Anyway, so what Josh worked out was, keep going. He mapped out all the timings, minimum and maximums, and he worked out that the timing is actually ranges. How do you set up a random state? I'm not sure what that question is. James, sorry. Sure, it's not for an SK. Well, SK6812 and WS2812B are supposed to be compatible, right? So what's interesting is there's like so many clones of the WS and SK chips now. The SK is a clone of the WS, but there are clones of that and clones of WS, and they all have different timing. So he worked out, so the segment length is standard, time between two low and two high edges, but the in-between low-high varies. No, that's the thing. It's not. It's not. There's a lot of leeway. So he worked out, for instance, that the high state for a 0-bit, the typical is 350, but it could be anywhere from 200 to 500 nanoseconds, right? And then the high bit for the 1, for an on, is anywhere between minimum of 550 and typical 700, but there's no max. And for the low bit, for both of them, it could be anywhere from 450 to 5,000. So that's like 5 microseconds. Like, look at that. I mean, it's the pixels don't care, right? And then the low point, so what you do at the end to latch it, so say, okay, I've got 175 pixels here. So I send 175 lots of 4 colors encoded as bits. And at the end, the datasheet says you're supposed to latch it for 50 microseconds, right? But you can latch it for as low as 6 There's so much leeway here, and fiddling with... So what happened was I was trying to work out why I couldn't get my color pixels working correctly, and you'd think it would be a timing issue, but it can't be a timing issue when all the timing tweaks I'm making are within the ranges of all of these, because they give you the same results. So the problem I've got now is, excuse me, I got to go right once, very lenient. It's great that it's lenient, but it also makes it really hard to find the exact issue of why things don't work. Why waiting for a full tick if you already know the correct color data? Next changing value would be another color, I guess. Well, that's right, but what it means is that there's all these libraries out there that work with some of the cloned or some of the chips and don't work with other ones because of the way they've got their timing. If you make it too loose, it won't work with some, and if you make it too tight, it might not work with some. And then, okay, so here's the issue I've got now. If you look at the screen, let me just minimize this. If you look at this, look how bright they are. Right? They look to be at full brightness. But in fact, I'm not sending full brightness. Look what I'm sending, 0.2983. Like the maximum value, I'm starting here. Let me start it again so I can get to the import RMT. I have to reset. 1 second. So there's a bug with the RMT implementation at the moment that if you break the code and it doesn't ever do a dinit on the channel gets locked and you can't reuse the channel until you do a hard reboot. He's heading off to camp soon, just a reminder. Thanks, Jim. Well, Yuz is going to let me know when I'm supposed to be saying goodbye. Hopefully Yuz will let me know. She's probably still getting ready. Anyway, yeah, so there's a bug at the moment which is going to get fixed. So when you do a soft reset, it will dinit, but right now it doesn't, so I have to do a hard reset. So if I do import RMT test 3, and I'm going to do it, and then I'm going to stop it really quickly. Okay, so I'm starting out, the values I'm starting at are 83 instead of 255. Oh, interesting. So, like, you know, if you send 255, 255, 255, technically you're getting... Oh, interesting, I'm not showing the W. Oh, I'm not passing it the extra... Oh, right, okay, that's fine. White is... I didn't add the white. That's okay. It's just on the display. It should be 83000. So normally, if you want to send full white, you send 255, 255, 255, right? For an RGB LED, and that's the brightest. That's red, green, and blue 100%, right? It's the brightest it can be, and it uses the most current, right? So the way if you want to get a duller white and use less power is like if you send 128, 128, 128, you're effectively sending half the brightness. So the pixel is half as bright, and instead of getting a pure white, you're getting slightly more of a grey white, right? I mean, everyone knows that maths, yep. So I'm sending quite a low value. I'm sending 83 out of 255 for the green, yet the green is still starts off pretty super bright, a paler shade of white. A less white shade of white. So the problem I've got right now is, so if I don't increase this rainbow, so I'm just going to let them all be green, okay? Just going to copy it back over. Oops. Going to do a reboot again. Import RMT test 3. Oh. Live typing sucks. What? Line 63, invalid syntax. What did I do? Oh. Sorry, I started typing something then. I forgot to finish typing it. Okay, so that's all green. Now you look how bright they are. They're full brightness green. But I'm sending 83 as a value. Avoided the timing consistency of the various creating zone near pixel timing pulse generator. Yeah, sure. He's got a nice hardware solution for that. That's great, but you know, that's not what I'm trying to achieve here. Might be a great use for the Glasgow board. Yeah, timing analyzer. It's probably not a bad idea. So if I send, okay, let me I'm going to save this file as a new one. I'm going to call it test4, because why not? Because we're doing really bad file naming right now. And what I'm going to do instead, yeah, I want to look at a full green and a not full green. So I'm going to create, we're going to do some colors equals, I'm going to go to 55 comma, actually no, I'll do 0 comma 255 comma 0. So I'm going to go full green, right? And then I'm going to go 0 comma 128 comma 0. And then I'm going to go 0 comma 64 comma 0. I'm going to do 3 shades of green. Okay, so I've got a full brightness 255, a half brightness, and a quarter brightness green. Can everyone read that? Okay, I hope they can. Okay, just for argument's sake, we'll also go 0 comma 32 comma 0. And what I'm going to do, so I do a clear. I'm just checking what I'm. Okay. I'm just going to get rid of a whole lot of stuff I don't need for now, just to not confuse things. I'm going to go through and I'm going to say, R comma G comma B. Actually, for val in colors, rainbow. So I'm going to cycle through each of the colors one at a time, and I'm going to display them visually looping around, right? I'm going to encode those. I'm just going to print them out as well so we can see what they are. No, hang on. Okay, I'm doing this wrong. Just hold on one second. RGB equals colors rainbow. So I'm going to extract the RGB out of the current color, and I'm going to display them on the screen so we can see what they are. And then I'm going to cycle through each one. In this case, though, we want G first, then R, then B, because that's the color code. And then I'm going through and I'm doing I'm processing the data. At the end, I'm adding the white. Okay, and then I'm going to increment rainbow. I'm going to say if rainbow, can't spell. So how many have we got in there? 4. 1, 2, 3, 4. So if rainbow is greater than 3, rainbow equals 0. So I'm just cycling it. Actually, you know what I could probably do? Even easier. I could say rainbow equals rainbow plus 1 mod 4 So that should wrap it. Do I want 4 or 3? I don't know, we'll find out soon enough. Won't be half as bright as 255. The brightness of those pixels is non-linear. Yeah, I know that they're not. Yeah. Visually, it won't be half. I get that. If you send increasing value starting at 1. I don't have enough. Like, I don't have 255 pixels. Sorry, I missed a whole lot of chat. Look, we'll start with this and I can play with the values, right? Assuming this even compiles and works. But I don't want to do it in a loop. I just want to do it once. Okay, so I'm just going to do it once, fill it up with cycling colors and see what happens. Okay, this will be interesting. Let's reboot it. Whoops. Okay, I'm going to copy RMT test 4 pyboard REPL import RMT test 4. Of course there's an error. List object isn't callable. Oh, I hate live coding. Oh, what am I doing? Square brackets. Have I missed chat? What's going on? Set the brightness overall. Right, so I can do that as well, Michael. Like I can have a brightness multiplier, but right now my multiplier isn't working. What I need to do is I need to see the data that it's trying to send and try to work out why I'm not getting differences in brightness. Because I don't believe I am. Maybe I am, and it's just like I haven't been going low enough. I don't know, but we're about to find out. Oh, right. Again, locked up channel. That's fine. Port. I'm right on the cutting edge here, folks. There we go. Okay, so I am getting brightness. Well, there you go. Look at that. So it is working. Pretty sure it wasn't working yesterday. But it's definitely showing us. Well, there you go. I'm a fool. Maybe I'm a fool. It's possible I'm a fool. A very musical stream. Why is that? What? Live coding with my flesh. Yeah, that does seem fine, doesn't it? Okay, so it could just be that the first two colors were so close. The 255 and 128 are just so close that you... I mean, on the camera it looks very different to what I'm seeing in real life. In real life, I can't see much of a difference between those two colors there. Like that, I definitely can't see a difference. We are all fools. No, I'm the biggest fool. I am the biggest fool. So, hey Gary. Okay, so let's have a look at this data. So what I'm going to do, I'm just going to send 5 pixels, right? I just want to see those 5, and I want to look at the data and see what they do in the logic probe. So what I've got, it's going to be a bit hard to see. Let me just go here and see if I can do it. So I've got my logic probe hanging off the edge here. I've got it connected to channel 0, and I've got my probe. I've got my probe here connected in between the data. So my data's coming out of pin IO15, and I'm just intercepting the data, and I'm going to trigger that on my logic probe. Okay? So let's get all this ready. I'm just going to send the 4 pixels. That way we know we've got one set of data that we can work with. So here's my logic probe UI. We need to use a human perception color space. Possibly. So on channel 0, I can't make this UI any bigger. Sorry about that. It's going to trigger on the first up it finds. And so I'm telling it to start. Oh, why is it triggering? That's interesting. There should be nothing happening on that channel right now. Let's try that again. What have I set it to? Options, stream. 3 channels, yeah, that's right. Why is it triggering? Should not be triggering at all. There should be nothing happening on that channel. 1 second, folks. Okay. It's yeah, that's really weird. Because that code's not running in a loop. So that should not be triggering. There we go. Okay. Weird. Okay, so import RMT test 4. And it grabbed why is it doing that many times? It should only be doing it pixels 5. Let me just clear them all. 175. Sorry folks, again, live coding. No, I'm not in a loop. I got rid of the loop. I'm in a loop for the number of pixels. And I'm telling pixels to only be 5. So maybe I just didn't copy it over properly. It's possible. There we go. Why didn't it clear the last lot? Clear 175. Oh, I'm not clearing the white. My bad. So this code was set up originally to run off this, right? Which has only got RGB. But this panel here's got RGBW, which I mentioned before. My own fault. Sorry. One more time. Import RMT test 4. That should clear it. And display it. Excellent. Okay. What did I miss? Hey, David. If I've missed a question or anything, please at me and do it again. What I'm also going to do actually is I'm going to copy the file over. Test 4 as main.py. So every time I reboot the board, do a soft reboot, it'll rerun the code. Alright, so if I do Control D, it reruns it every time. Control D, which is great. So I can now be on this screen, or easier anyway. So, do a start. Why has it got data coming through? It's interesting. It shouldn't be. And I'm turning it off at the end. And just restart this software. It doesn't matter because the data's right that it's capturing. So let's have a look. Let's go into the first lot of data. Oh, it's got spikes. What are these spikes? No, this is not capturing the right data. Maybe it's not channel 0. Maybe it's not plugged in properly. Maybe I've done something wrong. Let me quit the software and reload it. I've lost my mouse. Mouse is back. Wow. This is going really well. I said to Matt yesterday, I shouldn't be streaming this. This is going to end really badly. Yeah, this should not be triggering. What is going on? Stream all the capture data. One or two connections, floating ground wire possibly. No, it shouldn't be. Because I'm only using the one connection. I shouldn't need a common ground. Like I was using this all day yesterday and it was working fine. Just wondering if I'd done something when I moved it. It's possible. Let me try a different connection. Right, now I click start and it's waiting like it's supposed to be. That's what it's supposed to be doing. Okay, so I go here. I do Control D. And now it's not grabbing anything. Oh boy. This is wicked. What's going on? I'm unplugging it, plugging it back in. Is anyone here as frustrated as I am right now? I don't know why this is capturing. It's not supposed to be. It's not capturing anything. First user step. Yeah, power cycle. Single. One simple trigger. Which is correct. Who cares about the timing? Something is weird. You enjoying the show? I'm not enjoying the show. Sounds new iOS acting up. iOS? Hey Marcel. Got here pretty chill from okay. Scope it. Yeah, except I can't show you the scope of my stream now, and that's the whole point of using my DS Logic. Like none of this is data, as you can see. It's just not capturing properly for some reason. It's capturing garbage. And it's not doing anything. Wonder what happens if I unplug my tiny Pico. So there's nothing there now and do a capture. There's nothing. If I plug it in, yeah, that's not good. Wow. Try to pull down resistor on what? On the data line. Yeah, I shouldn't need one though. Again, I've been doing this for 2 days. Or yeah, since yesterday morning with the logic probe. Whew, interesting. I wonder if I can trigger it on something else. Stream mode doesn't do anything but simple. Okay, great. What's if I trigger on a high? No. I'm seeing webcam garbage. What? With some boards and lost them in my mess. Yes, we feel your pain, by the way. Did you set as a trigger voltage on the logic analyzer? Yeah, like it's got a threshold of 1, but that was working yesterday. I can definitely change the threshold. Make it 2.2, but it shouldn't need it, but we'll see. Okay, got to capture that time, right? Okay, there we go. So for some reason my logic threshold has changed. Thank you for that. Who was that? Who wrote that? Whoever wrote that. Felix. Thank you, Felix. I'm not sure why today was a problem. Okay, so here's the data. And as you can see, it's really not overly intuitive to see. Just by visualizing the data like this, you can't easily see where the 8 bits are per pixel, per color. Let me just move it over more. I wonder if can I drag this down? Can I make them taller? I don't know if I can make them taller. There's no menu for this thing. Options. Yeah, well spotted, Felix. I can't scroll this. I want to make it taller so you can see the highs and lows easier. Anyway, if I zoom right in, what I can do with the logic probe is I can look at a whole length. Right, so I can see that this whole period is 1.2 microseconds. I wish I could see that bigger. And then I can see what each section of that is. So that's 800 nanoseconds, which is 0.8, which is what I need. And then you got here, that's 0.4, 400 nanoseconds. Right, so I can see that these all look like there's an 8.4, there's an 8.4. But you can't tell from this, is that a 4.8 or is it an 8.4? Because you can't tell where the start one is. Right, so it's really hard to decipher the data. If you go to the very start of it, now I know that the SIGROC software, I think it is. Well, Mac, what do you expect? Oh, don't be like that. If I could put the lens on here and you could see it, that would be great. I can see it now really big. That's really awesome. But you can't see that. So apparently the SIGROC software might be better. I don't know. This is a derivative of it. Maybe there were more features in it. Max height. Where did you see max height? Was there a max height setting? 1 times. Oh, max height. 5 times. What'll that do? Oh, there you go. Well spotted. Brownie points for Andy Calloway. There we go. It's a bit easier to see. So that's the start. So you can see the first one we're sending is a 4 and then an 8. Right? Which means we're sending, if we go back to the code, the first bit we're sending is a low bit. Right? Because we're sending a 4 and then an 8. So what I'm basically doing in this code, just for those that didn't, well, I didn't really cover it properly, I'm going through every value, green, red, and blue, one like in a loop. Another free tiny pico. Free tiny picos for everyone. And then for each one of those, I'm doing 8 bits, and I'm getting the bit, and I'm saying if the value is more higher than 0, I'm then shifting each bit from least significant to most. 7 minus I. No, most significant to least significant. Plus you did advance a bunch since then. Yeah, okay, yeah, I'll have a look at the SIGROC software. I've been meaning to. As I said, I only pulled out the logic probe yesterday. Or the night before. So I'm going through every bit from most significant to least significant, and I'm saying, if the bit is high, then send it an 8, then a 4. Otherwise, send it a 4, then an 8. Which is basically just, it's deciding whether I'm sending it a high or a low. I'll eat an extra piece of pizza in your honor. Bruce, you got to share pizza for everyone. I'm actually suggesting trying out SIGROC PulseView. Yeah, I'm going to definitely try out the PulseView software. I call it the SIGROC software, but it's not. SIGROC is the device or the brand. But yeah, PulseView, I'll have a look at it. And then at the end, I'm just sending another bit for the white to tell it to be low. So that's what we're seeing. So in this case here, we've got a low. So let's see if we can count 8. I'll do my best. Whoops, went too far. And the other thing I can't work out on here how to zoom to fit. Like I want to just say fit everything in, and it's not letting me do it. Under the right conditions, they explode. What? Logic probes explode. So I'm trying to get to the start of this. Okay, that's really annoying. Okay, let's try this again. I want to see if I can count 8 of them for the first 8 bits. So we have a low, 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 low. Now that's really weird because if it's green, these should all be highs. Because the first value we're sending is green. We're going green. Let's print out the bits, shall we? Let's print... let's go here and print out... I've got to work out, see if I can format it. 1 second. 1 moment, please. Whoopsie daisy. Just 1 second. I've got some formatting code for this thing, so I can print the binary numbers nicely, apparently. But I need to find out where it was. Matt sent it to me. Of course he did. Because Matt is a... MicroPython guru, and I'm not. So he's the guy I bug all the time when I can't work stuff out. Can you make a protocol decoder for the DS Logic software? Can I make a protocol decoder for it? I don't know. Can you extend the software? What do you mean? Sorry. I mean, it's. Can you write custom software for the hardware, Adam? I have no idea. Yeah, that's not. Yeah, okay, I don't know where it is. Okay, that's fine. I'm just going to print it out. Print binary of the val. It's just, the problem with doing this is it's going to chop off the numbers we don't need. So we don't see the full binary, we don't see the full 8 bits. Copy RMT test for pyboard main.py. Okay, I'm going to rerun it. So we can see the bits here. Hopefully we can see the bits here. Python looks odd to me. There are no brackets to encapsulate blocks. How on earth does Python know? It uses indentation. And I thought it was really weird and yuck to start with, but I have to tell you, going to go ice my knee and watch the whole thing tomorrow. Did you hurt yourself, David? Sorry, I must have missed it in the chat. Did you get hurt at football tonight? Sorry, mate. I hope your knee gets better. Do it in the for loop, as you're not printing what's being sent. Right, but I can't append. If I do it in the for loop, I can't append it like, you know, with serial print and serial print line. Doesn't work that way. So what I'd have to do is I'd have to build the string and print at the end. See you, David. So you can see here what it's supposed to be sending here is a 1 1. So for the green. Hi, Orly. Hey, everyone, guess what? Orly's here.
Hi.
You going?
Yep.
Yeah? Off to school camp?
Yep.
Come here. Have an awesome time, kiddo. I love you.
Okay, bye.
Have fun.
I'm bringing back some raspberry drops.
Thank you.
Where is it?
What? Mum didn't print.
Oh, now I'm going to have to wait.
Okay, ask her to print it. Oh, is she printing it now?
Yeah, I think so.
Okay, just go check that she's printing it. Sorry, folks. Hey, Monster Mark. Sorry, Ollie came to me instead of me going out. That was very nice of her. Who is calling me? What? I don't know. She's coming back. Coming back. Everyone's saying have a great time at camp and have fun.
It says looking for printer.
Really?
Yep.
I don't know what your mum's done. Hey, folks, let's take a quick intermission. I need to work out why Yaz can't print. I'm just going to mute it. You can keep watching the vision, but I'm just going to mute it for a second. And so everyone go take a toilet break. Back in a second. I'm back. Quick, someone hack and download PulseView. I'll play with PulseView later. I'm not going to do that on the stream. Who isn't IT support for the Holy Standard family? Yeah, I know. It was printing fine. By the time I walked back out there, it was printing. So, okay, so we're back. I hate being the IT support. I don't do it for anyone anymore except for here. For many, many years, I was the go-to guy from everyone. Family, friends, whatever. No more. So back to this screen. So as you can see here, we're supposed to be sending 111111, like basically 255, right? But that is not what I'm seeing here. What I'm seeing here is high of 400 nanoseconds and then a low of 800 nanoseconds. And that means high of 4 and a low of 8, which means it's a 0 it's sending. And that doesn't make any sense. Problem in share, not in computer. That's actually really funny. What's PEBCAC? My sister could design a blood cell though. Somebody moved something on his desk. Ian, that's nasty. I still can't find anything on my desk. I've made the biggest mess for myself here. So why is that? I don't understand. Maybe I'm missing something. It's definitely, unless it didn't do the whole capture. Let me recapture it. It's possible that we're not seeing it from the start. Maybe I didn't give it enough capture space. Capture time, let's give it a bit more. Let's give it 500 milliseconds, which is stacks. No, it's definitely a low than a high. Oh, put your hand up if you're an idiot. Put your hand up if you're an idiot. Yes? Ugh. So the first thing I do is clear all of the pixels. I clear them all. Can everyone see the flash? Watch the flash. Oops. Oh, I was on the wrong screen. I clear them all. So when I do this, God, I'm an idiot. I'm an idiot. When I refresh it, you see they turn off and back on again? So it's clearing 175 pixels. I am an idiot. Let's just turn that off for now. Just means you won't see the clear state. Wow. It's just one of those days. Seriously, one of those days. Okay. Try this again. Okay. Start and capture. Yay. Okay, now that's right. Oops, wrong screen. So, there's no clear now. Now we've got a high and a low, as you can see. Whoops. I don't want to be on measure mode. Okay, so we've got 0.8 and then 0.4. Okay, so let's see if we can capture the first 8 bits. Try that again. Oh, gosh. This is a really bad piece of software, folks. Really, really crap piece of software. Where's my data gone? Wow. Does anyone know how to frame to fit in this? It's a learning stream. No, it's definitely a terrible stream. This is sucks. Anyway. So, our first 8. We've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's our 1111. Where is it? That's our 11111. Then we're sending 0 and 0. So then our next 8 is a low, 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 low. And then we should see a high and then a low after we've got our 4 lots of, or 3 more lots of lows. And here we go. Here we've got our high and our low, 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 low. Does that make sense? What's the name of this software? It's called DS View, and it's a, originally it was a fork of the SIGROC software, Pulse View or whatever it was called back then. And they rebranded it themselves, and they made some modifications. It was big drama. They didn't. It was open source, and they didn't contribute their changes back like they were supposed to according to the license. And there was a whole big drama about it because this is out of China. But apparently it's all sorted now. So now what I wanted to show you was if I go and change this timing. So if I make this, I don't know, 7 and 3 and 3 and 6, I don't know, 3 and 6, oops, 3 and 6, and if I change the last pulse, instead of being 500 microseconds, if I just make it, I don't know, 9 microseconds, right? And if I reload it in, as you can see, it still works fine, right? And if I do that again and take a capture, here's our capture. As you can see here, we're now at 700 nanoseconds and 300 nanoseconds. So I've changed the timing by a factor of like 10 to 15%, and the pixels still work fine. So what my concern is when writing a driver library for MicroPython for RMT, right? Because what I'd like to do is ship a NeoPixel library, basically, that for the ESP32 specifically, that implements RMT. What do I use for my pulse widths to make it compatible with as many as possible? Or do I, at what point does it fail? Well, I don't know. So if I go back to that, the website, right? So this is the range. Like I could have made that as low as 2, right? I could have made it as high as 5 for that first high. Like let's try it out. Let's go to minimums. Let's try the minimums, shall we? So the minimum says for the high for this one. So that could be 2. And for the low, 450 or 6, I'll have to make it 5 because I can't do 450 because it's an int. And for the high, it's saying I can't do 550, so I have to make it 6 and 2. So these are the minimums that he says. 2 and 5. And I'm gonna put the clear back in just so we can actually see that it hasn't that it's updated correctly in case it fails. Why don't you make a timing user definable? Good news is the pixels are not too timing specific. It's good that they're not, but it's also bad because these pixels aren't too timing specific, but other ones are. So that, as I said, there are a lot of libraries out there, like even Fast LED doesn't work on some pixels that you get, especially some of the cheaper stuff from China. Let me just reload this. So you should see it flash off and then on again. Right, so that still works at that lowest timing point. Those timings are probably temperature dependent too. Oh, you think so? He didn't mention temperature at all in his document. It's quite an interesting read actually for those that are interested. I'm just going to paste it in here. It says it's a really good article. Yeah, he goes into quite a lot of detail. Right, he's going as low as 2 here. Did I go to 2? Maybe I did. Yeah, I did go to 2. Right, okay. Yeah, so like, okay, so how do I make the timings user definable? That's the problem. You know what I mean? Like, then people are just going to arbitrarily stick numbers in, and how's that really going to help? You know, and then once you, I mean, it's got to default to something, I guess. Yeah, I guess I could always make a method that says like set, because you have to set both the high and the low state of each. Like someone's going to have to understand how the timing works to understand what to set the times to. Does that make sense? Because it's the way it's encoded, like they can't just set one like a high and a low. They have to set a high and a low for high and a high and a low for low. And I'll also need to give them the ability to set the reset, the latching time, somewhere between 500 microseconds and 6 microseconds. No, 50 microseconds and 6 microseconds. Batch of 22 SKs had timing issues when the previous batch from the same LE store worked. Yeah, it just depends on the chips that are used inside. There are so many clones now. And then the other thing I don't know is you've got like WS6, 2812, 2811s and 2812s and 2812Bs, and then there's 2813s and there's a 2815S now. Like there's all the different versions, and they're all coming out from different people. It's not like they've all been redesigned from the original manufacturer. So I don't know, like from a timing point of view, what I don't want to do is try to build. So in Fast LED, in the Arduino interface, they build. I'm just going to switch cameras. They've got all settings. Like you basically say, this is my pixel I'm using. It's an APA. It's a WS, 2811 or something else, and then they come up with the appropriate timings. But I'm sure that the guy that wrote that has spent lots of times with lots of different pixels. Like I don't want to go out and buy 100 different types of pixels and try to work out which one's which and try to come up with a whole bunch of profiles. You know what I mean? That's just not a good use of my time, especially for a library that's not going to get used by many people, because let's face it, there are 100,000 times more Arduino users than there are MicroPython users, unfortunately. Sounds like you're going to need to decap and reverse engineer the chip. Not a chance. Not a chance. What if you put 2 pots and 2 analog inputs, one for mark space, one for ratio of timing of the bit frame? Hey, Gene. Sure, but that's going to help me just for my pixels that I've got. You know what I mean? So these are, the ones I'm playing with right now are GRBWs, and I've got some other GRBWs here that don't work as well as these ones do. That I couldn't get them working with the with the Adafruit library, and the Fast LED library still doesn't officially support the W. But these ones do work, and I've got these working with the Fast LED library by hacking it, but I can't get my other ones working by hacking it. So, I mean, again, that's my concern. Build a from discretes. Yeah, you can do that, Azzy. Go for it. This calls for a near pixel timing calibration board. Yeah, I wonder if you could do that with the Glasgow. It's listed as RGB LED. What's listed as? Off stream, have a look at the decode menu. Off stream, have a look at the decode menu. The DS Logic. It's got a decode menu, does it? I don't have any menus at all. Oh, that menu. Right, okay, sorry. No, I'm not going to do it off stream. Let's have a look. So decode. You're going to tell me that there's an option for... Oh, whoops. No way. No way. As I told you, I only plugged this in... What are we? Wednesday. Monday night, I plugged this in for the first time. Pulse has... Right, they both have. Okay, so WS... Where is it? RGB, RGB LED. Okay, so how do you use it? Anyone know how to use it? Like I've put that in. So what does it do? Do I have to run it again? We run it again. I don't know I don't know how to use this software, folks. Settings. Decoded protocols. I just download the software to take a look. I don't have one and have no idea how it works. I don't know how it works. Okay, I mean, I've got the protocol listed. But how do I... Protocol list viewer... Like, yeah, I don't know how to... I have to do some more. Ship library with a selection of timing configuration profiles contributed by the community. How would the community... No, so the thing is, I can't do that. Well, I don't want to do that, because what I want to do is I want this library to be frozen inside MicroPython for the ESP32. One of the features that the MicroPython guys... I'm just going to switch cameras. One of the features that's being worked on for MicroPython right now, as I've mentioned before, that there's board level stuff. So there's now a specific version of MicroPython for the Tiny Pico, for instance, right? So you'll be able, it's unfortunately it's not on the downloads page yet. It will be at some point. So when you go to download a pre-built firmware, there'll be one specific for the Tiny Pico that has all the Tiny Pico helper libraries and stuff built in. So that way it doesn't have to ship for all the boards that isn't relevant for, right? One of the things that they're doing on a per board and a per ports thing is to also have, or they've already got per ports, is frozen modules where, I want to be able to include a NeoPixel. There's already a NeoPixel driver in there, but it's bit banged, right? So it has the issues of flickering pixels and stuff. I want to include this RMT implementation, but it's going to be frozen. So because if it's frozen, you can't plug something else into it. Does that make sense? So I don't know how users would be able to contribute that unless, the only way would be to keep rebuilding the firmware of MicroPython and keep updating your firmware. And that doesn't sound like a great way to do it. There needs to be a way of being able to, maybe I can write it in such a way that you can pass it a timing profile. So that way you could copy and paste a profile from somewhere into it. Just pass it to a method. Looks something very different than PulseView, so I can't help you. Nudge, nudge. Okay. I'm going to download PulseView. I'm going to do it right now in front of you all to prove it as well. Mac OS X. PulseView, stable, nightly, stable. Do you want stable or nightly? Let's do stable. Okay, I'm downloading it. I'm not installing it now, but I'm downloading it. There you go. I will have a play with it. Hit the plus button next to the decoder menu or pop up a box. Then select the data line to decode. There you go. This is you're all going to teach me how to do this. Plus. D in data line 0 to end stack decoder. Hang on. It might not decode it because it's got a W component, so it might not work. Okay, it still hasn't. Now start mansplaining to Sion. Oh, I'm quite happy for you guys to do that. Bruce chose nightly, living on the edge. Yeah, I normally do that actually myself. So yeah, I don't know how to decode. Like, because you can't grab a selection in this. Like when you try to click and drag, it just moves the screen. Turn off the RGB option and only show bits. Turn off the RGB. What? Oh, turn off RGB and just show bits. Okay, but it's not showing me bits. Shouldn't it be showing me up here what it is? I don't know. Yeah, I'll play with this later. I've been wanting to learn how to use this for quite a while, and this has been a good opportunity to at least start. Like I had to learn how to trigger it and all sorts of stuff. Has it color coded the waveform for each 8 bits? Yes. So there's 4. It's got 4 bytes per pixel per LED because it's got a white component on here. If I don't encode the white, obviously all the data gets skewed up, and then it so encodes all of those, and it does for every pixel in a row. But the software's looking for RGB or GRB, so it's gonna not show me the right values anyway. Joel on OpenTech Lab, who developed PulseView, has a great video on using the software. Okay, thanks, Simon. I'm going to definitely look into the software. And I'm sure the DS Logic software is quite capable. I don't know. I just don't know how to use it. It's just one of those things. Just a timing thing. Like I still don't know how to use my scope properly anyway. It's the same thing. Might just figure out 3 to 5 timings to include. Just choose one. On the DS view seems to be white and grey at some zoom levels. What do you mean white and grey? You mean when I go like this? Yeah, I think they just make it... I don't know if it's the same colour or not. It looks slightly transparent or whatever. I don't know if that's white or the same colour. I think it's the same. Make it heaps easier to read what's going on. The bits, though. No, it won't decode the colours, but it'll show the bits. But it's not, though. If only I could work out how to do it. Oh, I can move them around, can I? That's nice. But why does it not show me bits? What does display do? Themes. Oh, I could got light and dark theme. Ugh. Oh, no. The world has to be dark theme. There we go. It's better. Oh well. Work it out at some point. So. What else can I tell you? So one thing I haven't solved yet, though, is if I just go back to here, to RMT, import RMT test 3. Oh, that's right, they're all green because I changed my test 3, didn't I? I want it to be colors. Let's go find test 3 again. Where's test 3? I really need to close. You see all the files I got open? Oh, I don't have it open because I saved it as 4. Open test 3. It's interesting. This should be GRB. G, R, B. Save that. Hey, Cran. Pretty good with this software considering you've never seen it before today. We'll make it heaps easier to read what's going on. What will make it easier? Oh, right. Sorry, I missed that bit. Yep, okay. Copy RMT test 3. It's going to want me to reset it. Test 3. Color. Oh. Oh, I forgot to increase the rainbow. And why is that doing... Oh, I must already have it coming back in the right order. Oh, boy, folks. Okay. What is the Glasgow board? The Glasgow board is the next product that Peter from 1 Bit Squared is doing on Crowd Supply. And it is a Swiss Army pocket knife of full-on hardware inspection and decoding stuff. Did you post a link to it before, Peter? I don't even know if Peter's still here. Oh, there we go. And a different Peter posted. Thanks, Peter. Let's try that again. Reset. Import RMT test 3. There we go. So those colors are dull, like they're supposed to be. They just look super bright still, don't they? It's quite amazing how bright they look, considering. Super Magic Bus Pirate-like thing. It is. Oops. So if you look at how bright, I mean, they look pretty intense, and that's going up to a maximum of 83. So that's, you know, what, a third? Yeah, I divided by 3, as you can see here. So let's divide it by 4 and see how much softer it gets. Import test RMT test 3. Right. I mean, that's still pretty bright. That's 1/4. These RGB LEDs are 1/4 now. And that is pretty crazy how bright they are still. They are quite nice colours. Now, for those no one's asked, which is quite interesting, I am running this off 3.3 volts, not off 5 volts. And I'm running this off my Tiny Pico through my USB connector. So this, even when you saw it, like I'm going to do this, I don't know what's going to happen. We'll see what happens. Let's do it at 100% brightness. Let's see if I can destroy my Tiny Pico. And when I say destroy, I mean not just blow it up, but let's see. Like, it might start power cycling. So let's see what happens if I. So this is going to be 100%. Reset it. Who wants to put dibs on whether it does a hard power reset? Here we go. Import RMT test 3. Cross your fingers. Wow. So that's full brightness. Well, pretty much 249. Whoa, that is bright. Are we back? I think we're back. I took all the power down, you see? Too much power and I took it all down. Yeah, it looks like that. It's a 2-hour mark or something. It's just OBS. Are we back, folks? Give me a thumbs up if we're back. Wait for it. Wait for it. So that was funny. Are we back? Yes? No? Okay, wow. We were back, but I didn't hear a response from anyone, so I did a reboot again. Wow. So as you can see, it's definitely struggling with the power requirements. I'm not sure if you guys got that bit. See you, Jim. Catch ya. I killed the Chromecast. Sorry, folks. It's definitely struggling with the power requirements, but the fact is it's still doing a great job. But the interesting thing, though, is... No, these are RGB, GRBWs. They're just strips of pixels I got from China. This was the board I made. I got a video for it. You invented an instant buffering device. Let me just, I'm going to put this back to /2. I'm going to drop the, yeah, it's too bright. Actually, I'm going to put it back to /3. And copy it over again. Because that's, yeah, I'm drawing too much power. But it's pretty cool though, right? How much it can do. But did everyone catch the key thing here? Is the regulator getting toasty? No, it's pretty good. It's, no. Data would handle of all 255. No, that's the thing, right? You got to remember, I'm not doing pure white of everything. Yeah, and I'm not using the white channel at all. And I've got the white channel to do white. So it's not using, yeah, it's only, even at full brightness for the color, it's still only a portion of each. But what I wanted to import RMT test 3. Let's just do that again. This is lower brightness now. As you can see now, the blues are working okay because it's got the headroom now for that. But what's interesting, right, the key thing, when I got to the key thing is, much to everyone's, you can't do it, I'm driving these off 3.3 volts, not 5 volts. Right? There's no flickering. The colors are working fine. Looks like in-win 309 addressable RGB front panel. Hey, Messi. It's just a custom matrix that I made. I've got a video about it, or a couple of videos about it on my channel. But it's driving up 3.3 volts, and that's something that apparently you're not allowed to do, or not supposed to do, on RGB pixels. What, James? Hey, random stuff guy. So, you can measure the current being drawn in total. I could, I guess. But I'm not gonna. Yeah, I draw I've never had a problem. Right, and I've done it quite a few times, but I have had problems in the past, like with my laser Wi-Fi clocks. I had some issues with 3.3 volts. I guess it just depends on the pixels. But the first thing I started playing with on these the other day was driving them off 5.5 volts using my which you can't see properly with the lightings. I've turned it right down, but using my I/O expander that has my level shifted 5 volts. But it turns out I didn't need to. I could just drive them off 3.3. And it was working great. My guess is because of the forward voltage of the blue LEDs. Turn down the volts. Well, I can't turn down the volts. It's running off a tiny pico. So I don't have volts control. Lots of them work through 3 volt logic. The big problem comes when you power them from 5 volts and send data to 3.3. Sure, yeah, you need to go 5 volts and you need to do level shifted logic. But I've had a lot of situations where 3.3 and 3.3 hasn't worked properly. The external electronics consultant we used did not like my attitude. What do you mean it works? What? See you, Tinker Dad. Sorry, I didn't see you say goodbye. So, yeah, okay, well. So VCC 3.3 as well, that's right. You got that 0.7 headroom, but there's a lot of pixels that just don't work with 3.3 volts. And with my experimentation with this, when I built it really early on, if you could be bothered going back to those videos, I had trouble running these off 3.3 volts off an ESP32. Apart from the flickering, I was having a problem off an ESP32 at 3.3 volts, but I could drive them off an 8266 off 3.3 volts. What is that actually? What is what actually? Sorry. From the Lylon and that worked. What? Oh, lithium ion battery. Right, okay. If this was 5 volt pins, there would be a problem. There's sometimes a problem. Again, I've driven off 5 volts with 3.3 logic before and had mild success with it. Generally, you lose the first pixel data, but then it fixes itself. I mean, we can try that now. I can unplug power off 3.3 volts and plug it into 5 volts and see if we get corruption. Okay, that's now powered off 5 volts with 3.3 volt logic. And for those that don't believe me, okay, the lighting here, I need to lift the lighting up so you can see. I've got ground and power, and it's ground and 5 volts. So that is 5 volt power, 3.3 volt logic, and that is working. RGB front panel. So what is my opinion about? I don't have an opinion because I don't use PCs. I use a Mac, and I don't have an in-win case, and I don't RGB anything to do with my computer's messy. So sorry, I don't have an opinion at all. Can you do a BMS circuit 3S next time? So can I do a BMS circuit? No. That's not what I don't play with battery walls, balanced batteries and stuff. There are plenty of other YouTubers that do that. Check out Adam Walsh, check out Colin Hickey, check out anyone else want to help me off the top of my head. Hey John, you're late. Yes, stream started 5 minutes ago. Who else does BMS stuff? Might not be consistent across strips, drivers. No, it's not consistent, Adam. That's my point, right? That I've had problems in the past doing it. But as I said, what I found was this was much more tolerant to. Yeah, Julian is doing balance. Yeah, okay, yeah, okay, yep. Julian does balanced stuff. Not really working on his own. Yeah, he did work his own circuits. Yeah, okay. He's not doing power walls though, is he? Or he's still. I guess he's got his pack that he's working on. Sure, but isn't he doing super capacitor packs? BMS is a balanced charging system for batteries. So when you've got a bank of batteries, like, you know, whatever type of batteries, one of them's always going to draw or like lose capacity more than others. Like they all will discharge. They'll all give off power in an unbalanced way. So a BMS is designed to make sure that they all stay the same, because if one battery depletes more than the other one, you can destroy the battery. So they allow batteries to, correct me if I'm wrong, but they make sure that the battery draw is more even of the current coming out, and they can kind of recharge each other to keep them all at the same level, so they all go down at the same time. If that makes sense. What's Adam saying thanks for? I don't know, he's got big batteries on his backyard. Yeah, he does. Yeah, I guess I was thinking more power wall type stuff, like what Colin's doing and Adam Welch is doing. But yeah, you're right. Yeah, Julian's doing all sorts of stuff. So yeah, there's lots of YouTubers that are doing stuff like that. That's not my space. I don't play with stuff like that. So definitely won't be making one of those on a stream. Yes, the whole thought of doing balancing batteries and power walls through batteries scares the bejesus out of me, just like AC power does. But yeah, what was I saying before? I always found that the 8266 was definitely more tolerant, or this was more tolerant of the 8266, but I had zero results using my ESP32s on this before. But RMT seems to have fixed all of that, which I'm finding strange, because I feel like the fact that I'm not bit banging makes the logic tolerance different. Like it makes it, doesn't eliminate it, but it definitely reduces the issues from it. Like I'm pretty sure I could go and plug this into any. Well, let me plug this in. I mean, it should just. I mean, obviously there aren't as many pixels, but let me unplug this. Let me plug this in. So what have I got? Ground and power. So I'm going to go. Let's start off with 3.3 volts. Ground. Just to get a baseline. And 15. Okay. So that's running. Let me just put this over the top. Obviously the pixel order is a bit different. But that's running off 3.3. I live off grid all winter on a 500 milliamp hour battery pack. All winter? Really? That is crazy. My timing will be more accurate, but I feel like the fact that the bit banging, because it's not bit banging, that I feel like maybe the my rising and falling edges are going to be much straighter and cleaner, I think. Okay, so if I move this to 5 volts. Whoops, I pulled the whole lot out. Sorry about that. Get back in. And 15. I hope that's 15. Okay, and that's running 5 volts with 3.3 logic. Right? So once again, so here's two completely different types of RGB LEDs, and both are working 5 volt with 3.3 logic with RMT, which is something that hasn't worked properly before for me. I'm trying to think, do I have another panel? What other panel do I have? It's got stuff connected. Yeah, I don't have... No, I don't have anything else wired up right now. Sorry, nothing else wired up right now. That would be good if it make it random RGB of each pixel. Let's do it. For this, nah. I've already got a library for this, which works really great on the Arduino land. And now that I've got RMT working for MicroPython, I can write the library for MicroPython. So these pixels are looking much more pastel-y. Let me darken that off again. They're looking less bright, like they look more pastel colors because I'm dividing the color by 3. Let me just let me put them back up to full brightness to see what happens. Okay, I'm just recompiling. Just need to reset. And copy that over again. I know you can't see the screen, that's okay. Import RMT test 3. Right, that's at full brightness. So some of the blues are struggling again at full brightness. Obviously way less pixels. There's 75 pixels here and this other board at 175. It's always that edge case on the bell curve that catches someone out. Sure, I'm not recommending to everyone that they should be using 5 volt power with 3.3 volt logic. Definitely it's something that's not officially supported. But I've just found that with RMT instead of bit banging, that my results have been far more stable and reliable, which has been really good. 120 microseconds full time. Yeah, I'm talking, I guess, more about the cleanliness of it. But yeah, sure. Levels revolve within those 5. No, the threshold levels for 3.3 volts, or for the logic versus VCC, is actually out. It's for the official spec of the WS chips, whatever they are. They've got to be within 0.7, which means that at 5 volts, 0.7 is 4.3, not 3.3, and they shouldn't work properly. Yeah, apparently the in-win case is fantastic. I'm not quite sure why we're still talking about it though. I think maybe Messi works for in-win. What do you think? I think my chat's turning into a let's talk about PC cases and stuff. You can cheat on the first near pixel, add a diode on BCC that lowers the threshold. Sure, you can do that. You can also stick a resistor as well. But you know, it's at the end of the day, that's when you're hacking it at the hardware level to it's not fantastic. You're better off just wiring it up correctly and having it work correctly. So I'm just experimenting a bit. Yeah, I think Messi, send me a free sample if you work for InWin. Otherwise, yeah, I think you need to stop promoting the InWin in my chat because that's not what my channel is about. Thanks. Okay, well, I've been going for over 2 hours and I think it's time to wrap this up. Unless anyone's got any questions or anyone's got anything else that would like to talk about other than BMSs or in-win cases. I'm just going to stop this from running. I'm going to power this down. My poor tiny Pico got a lot of abuse this morning because the front is exactly the same as my panel. I'm not quite sure it's exactly the same. Be interesting to see how fast you can update. Yes, I agree. Right now my problem is my library doesn't have any functionality to do anything other than set some color, you know what I mean? Like the NeoPixel library for the Arduino is really great because it hooks into their graphics library and then you can display text and do other stuff. In my case, I've got nothing to connect it to right now. ESD. Let's talk about ESD. No, let's not talk about ESD. We can talk about the fact that I didn't finish my coffee. And there's no way I'm drinking that now. My pick and place update. I don't have an update. But for those that really don't believe me, Wait, how can I do this without showing what I'm working on? Wait, need to hide something. Hiding. Okay. For those that still don't believe me, I've still, look at them. Might not be able to see. I've still not set up my pick and place machine. Look at that. All the feeders are empty. I still have to reload all of those parts. I've been avoiding my pick and place, reloading my parts. I've been avoiding it. I really need to. I'm honestly about to run out of the crotch shot, about to run out of tiny picos. I've got enough to send out my orders for today and tomorrow, and then I'm done, and I need to build more. So, manage a quick data transfer to ESP86 by sending buffer data via WebSocket and pushing it directly to the LED strips via WebSocket. With RMT, there's nothing faster than pumping out the data via RMT. Like, it's the lowest level of pushing data out. So I should be able to push it fast. I just don't know. I don't know what overheads there are, I guess, technically in MicroPython. Like in terms of its, like right now my overhead will be more about building the data that I need to send. Right now I'm building it in a way that allows me to view it and poke into it in code. Obviously, once I know it's 100% reliable, I can then, not do that, and I can be much more optimized in how I build my data and send it. I'm also, the HSV stuff that I'm using right now is not very fast. It's not overly optimized, and it's got to go through normalizing and denormalizing of data, so lots of multiplication and division for all the stuff. Like a lot of that stuff can be completely cleaned up as well, especially if I'm not using HSV. So, you're pumping it out through Wi-Fi. Okay. 30 frames a second, nice. So yeah, I'm hoping it can be pretty fast, but I need to work out how I'm going to build the visuals that I'm going to send through. Right, filling the panel is fast, that's right, it's the processing. So that's a whole different thing to tackle. How much that panel take in frequency? I have no idea, it's just strips of LEDs. It's no idea. Yeah. I mean, how fast can you send pixels? I think there's no... What's the upper limit? I don't know. I've never seen a spec on what the upper limit. I'm just looking now of it is. I mean, for 4 colors, what are we looking at? How many nanoseconds? 5. Let's call it 350 and 7. So 1 microsecond. 2. Low, 1. Let's call it 2.2 microseconds per pixel. 2.2 microseconds per bit. So what does that work out to? So per bit, so 8 times 4, so 32 bits for times 2.2 microseconds. 2.2, 70 microseconds per pixel. Okay, Adam just did the maths. Did it the other way around. Right. So 262 frames per second. Wow. That's pretty fast. Hey Simon, don't think the guy was trying to promote your PC case. He was interested in my RG panel to make his own case. Right, really? Okay, I thought he was talking about how the panel is similar to what's in the InWin. Oh, I'm not going to look back now. I thought the InWin had an RGB panel on the front. 8,000 times 800 times 1,000. I'm not sure what are your maths, because you worked it out differently to me. But anyway, still, that's a lot of frames per second. But yeah, and 32 bits, so you'll have to divide it by 32, not by 24. But still, that's still over 200 frames a second. I mean, how fast do you need? You just need a display to, what, 60? I guess maybe 120 would be buttery smooth. I don't know. I don't think I could... yeah, the bottleneck wouldn't be the filling of the data. The bottleneck would be the processing of what the visuals are going to look like. Push parallel bit streams to update faster. So in RMT, you can have multiple channels, but each channel has to be on a different pixel, a different GPIO. You could technically split a panel into multiple GPIOs. You just have a timing issue. Like you'd need to make sure that your processing was done, and that the number of pixels you were sending per channel would be even, and then theoretically you could pump out multi-channel. I wonder can't remember how many RMT goes up to. I think it could be 4, 5 or 6. I don't know. I'd have to look into it again. Will it run Crisis? No, it won't run Crisis. Pretty sure it won't run Crisis. It'd be pretty low res, let me tell you. It might have the frames per second, but it definitely won't have the resolution you need. Like, it'd be very hard to get a headshot out of this animation, this resolution. Could you not make your animation on one core and use the other for data sending? Well, no, because again, there's no CPU overhead for the data sending. Gavin, that's the whole point with RMT. It's really low level hardware. You're not bit banging it. It's one command. Or are you talking about the building of the buffer? Is that what you mean? I'd love to make a video wall. Will I sell the RGB panel? No, this is not a... So this panel is just lots of strips of RGB LEDs. Like, I've got a video on how to make it. You can just make one yourself. The only thing really about it is the fact that I've made a laser cut. Like a kind of a unique laser cut display at the front. But other than that, no, I'm not... It's not a product. It was just something I was playing with. But, you know, there are stacks of videos on YouTube about people making, you know, using RGB strips to make their own matrix panels. So definitely, you can find one of those. Sounds like a job for an FPGA to push the data out. Well, no, that's what I'm saying. RMT pushing the data out super fast. The issue is processing the data, like creating the data you're going to push, right? That's the whole point with RMT. You're not banging the data anymore. Like, you're taking this whole stream of bits, like I'm doing. I'm building a list of bits, and I'm saying, bang this out through IO15, and that's what it does. At a really low level, it goes and shoots the data out. Guaranteed timing, guaranteed delivery. Yeah, it's going to come down to what's inside that buffer, right? Yeah, panels are easy to make, just run a lot of power. Well, they're painful. They're easy to make, but they're painful because it's keep ripping the copper off those. Like, some of the strips you get, the copper pads are just terrible. Anyway, tiny Pico cluster using one to fill the panel, the rest to process the buffer. Sure. Or you could just use a computer, use a Raspberry Pi or something. Sort of like DMA. Yeah, but DMA is non-blocking, but DMA is still... Like, if you're going to push a whole bunch of data to RAM via DMA, you're still streaming the data. Does that make sense? I believe. Like, it's still... It's non-blocking, it's direct access, but you're still writing bits at a time. I mean, but at the end of the day, at the low level inside the ESP32, like, I don't know what it's doing in terms of how it sends it out. You know what I mean? Like how it does the timing, but it's at least from a coding point of view, it's a bang. Like you just, here it is, do it. Like there's one command here. There's one command here. It just send pulses, right? And it just, you pass it the data. In this case, in MicroPython, I'm telling it I want it to be high first, then low. You can, obviously if I set that to 0, it'd be low then high. And that's it. Like I just call one thing and it, at a really low hardware level, pumps all the data out. So that's the key thing here. It's copying RAM from peripheral, bypassing the processor. I understand what that's doing, but it's still got to be bit streaming it. You know what I mean? It's not like, it doesn't blit the data in. You know what I mean? It's not saying, okay, I've written, let's say I've got, I don't know what, 16K of something that I need to write to memory. It's not stamping the 16K down. Does that make sense? Like it's still writing the data out. Oh, wrong screen. It's still writing the data out, like, but it's doing it at a really low level. It's not doing it on the CPU. It's doing it at a low, yeah. But it's still got to technically write a bit at a time, ultimately, right? Does that make sense? So, like, RMT must be doing that as well, but it's at such a low level that it's. I don't know if you could call it bit banging anymore. That's the thing. That's what I'm trying to say. To confirm, you mean prepare the whole stream and then send as a single piece of data versus send it this and send that. That's right, but not just send it as one piece of data, but you're doing it. It's not the CPU that's sending the data. Just like with DMA, it's not the cores that sends the data. It's a peripheral, it's a separate bit of hardware inside the ESP32 that does it, and it does it at a really low level that has nothing to do with the operating system. It's nothing to do with the CPU. It's not running in cycles. It's not bit banging. Like it's just I don't know how it does it. Like it'd be interesting to kind of look into the hardware side of RMT to understand how that works. But yeah, just like DMA, it's super low level stuff. It's not running on the CPU. Although the Adafruit drivers are a bit different now, and I believe the latest NeoPixel drivers now actually, they don't implement RMT, but they implement a driver that fixes the flickering issue. They're bit banging, but they're doing port manipulation. But there's no such thing as a port on ESP32. Like, you got, port A, port B on AVR micros, and some GPUs are on port A and some GPUs on port B. And so you can grab port A and you can do a bit mask to set IO on and off. Does that make sense, right? So ESP32 doesn't have that. There's no such thing as a port. But you can do IO direct manipulation through some macros, but it's a bit messy. That's what they're doing now. So they've avoided the timing issue and the flickering issue that was in their driver by doing doing IO manipulation to get the performance. And it seems to work okay. But yeah, RMTs are, the reason that I think they went that way is they do that on more than one platform. Actually, I might even have some of their code open. Let's have a look. Just get in my car. See you later, Gene. I'm going to wrap it up soon, but this part might be interesting for some people. I don't know. But if you look at their latest, actually it might be in here. That's all their timing. Is that all the gamma? Actually, it's not in there. 1 second. I'm just switching camera while I do this because I don't. Be careful what I put on my screen. Okay, here it is. Right. So they've got a file now called ESP8266.c, or I don't know if it's new or whatever. But inside here, they've got all this code. They're doing register writing now. So instead of doing a bit banging like they were before, where they were going through their loop and they were saying, you got to go high, you got to go low, you got to go high, and they were using timers to make sure that it was right. They're now doing this GPIO register writing. And although it says 8266, I believe here, if defined ESP32, they're now doing it for the ESP32 as well. So that's how they're getting around the issue. And I think they're going this way because they've got other... They were doing this already for things like the AT-Tiny and stuff. They were already doing direct I/O manipulation because the AT-Tiny is super slow. Crowley got some minions doing his work for him. I haven't heard any crows. Not today. People always think I'd like to see what is going on. Anyway, so that seems to have fixed their stuff. But they're still counting the timing. They're still manually doing the timing, right? So it's still technically bit banging. You see here. But they're doing it at, they're not using, digital writes and whatever, and they're not even like they're doing as close as they can do to port manipulation to get the performance out of it. But my version, what I did for my X7 segment, I'm actually doing RMT. So. So it basically says if when I'm filling the buffer, if you're on the ESP32, then I'm doing RMT here, the writing. I'm grabbing all the data, I'm filling a buffer, and I'm pumping it out via RMT. And if I'm not on an ESP32, then I'm just using Adafruit's fallback. Kind of menu version. This new method makes way more sense than the timing fix thing, which feels a little workaround. You mean Adafruit's one? Yeah, I don't know why they didn't do RMT. I mean, Fast LED's got RMT support. It's not overly difficult to get working. I mean, I got it working. I got it implemented. Now I have to backport this to my Neo 7 segment drivers and my other drivers as well. Because my Neo 7 segment drivers, which is the first displays I made with first drivers, they came out forever ago, well before I started playing with ESP32s, and I wonder if someone uses that with the latest NeoPixel driver, maybe it'll work. I don't have to fix it. I don't know. A distilled DMA process is used to get data in or out of memory by separate logic to the CPU that only the setup of transfer the block gates work at the end of. Sure. I mean, DMA as a concept, yeah. I mean, that must be how they're doing RMT. Like, I couldn't work out, but it's as I said, it's a peripheral. Like, it's actually it's a bit of hardware inside the ESP32 that does the RMT side. You know what I mean? So I don't know how it functions. Like, I don't even know if there's any technical data on it. I'm pretty sure the silicon designs are not released for the ESP32. I wish they were. Be interesting to look at. If someone wants to delid an ESP32 and kind of point where the RMT peripheral is, that'd be cool. But yeah, be interesting to look into. RMT's only on the ESP32. From what I'm aware, definitely it's unique to the ESP32, which is why it's taken so long to get into MicroPython, just because it's it's like a DMA controller for pulse encoded data to GPIO. Right, but the question is, like, can it do the DMA side to get the data? Like, the data's still got to go from the CPU to the peripheral. Like, so it's got to go from your code via the CPU to the peripheral, or does it go from your code? Like, is it being DMA'd to a place that the RMT peripheral can get to send? Because it would seem like a bottleneck if the peripheral had to use the CPU to get the memory, if that makes sense. DMA signals completion. RMT does the same, transfers the specific data to the I/O function, SPI or other. Each byte sends loads. Next send DMA is only dedicated hardware logic. Okay, cool. Thanks, Helmet. Interesting. as I said, like I'd like to look into it more to understand better how it works. But right now, like I feel like I'm back in software land now, writing drivers and libraries, which I don't hate, but I much prefer making hardware. But it's a pretty cool technology. Like I'm surprised that more microcontrollers don't have it, or maybe they do and it's just called a different name, and it's it maybe does a similar thing. I'm not sure. But it is very cool, and it can be used for a lot more than just pixels, obviously. Address range in blocks directly from RAM. Where's everyone reading this up on? If you ever got links on YouTube or on Google, post them. Okay, I think it's time to go. I don't know what I'm going to work on once I shut the stream down. I might reload my pick and place, but probably not. I do have some exciting, exciting for me projects, videos coming up. Maybe not exciting for everyone else. We'll see. I'm trying to tidy my office, so I'm building some things to help me with that. Maybe that'll be interesting to people, maybe not. I doubt it's like an ISR interrupt in the background. It'll be hitting. Yeah, no, it's not interrupt driven. It's its own low level peripheral. Yeah, there you go. Have a quick look at the Winmouth case. You'll be surprised. Okay. One more link to Glasgow. So when's the campaign going live, Peter? Shop project Sion? Count me in. Yeah, they're very specific to me though. I'm not sure. That's what I'm saying. Like people might go, okay, that was kind of cool, but it's not really very limited use for other people, but kind of important stuff for me. My next video, so Friday's video, will be my first one of them anyway. I'm going to spend the day learning to build Docker images. That's interesting. I need to learn how to build Docker image. I know what Docker is and I've never used it. And I really need to. I need to start creating some Docker instances, or whatever they're called, for my development stuff to keep things separate. Because like right now, when I'm developing for this, which, haven't even told anyone if it works or not yet. You're going to have to wait for that one. So when I'm working on this, I need to use a different version of IDF and a different set of environment variables and stuff than regular ESP32, because it's proving quite difficult to do all that without creating completely isolated environments. So I really need to do that, but I just haven't got around to it because it's another thing to learn and I don't have the headspace for. I still can't even learn Git. That's a whole different story. We'll talk about Git another day. Docker is very cool. I get it. I know it. I understand what it is. I understand what it's for. It is very cool. It's just another thing on my list that I'm never going to get to. or yeah. I don't know. Well, I shouldn't say never. It's just like I need the knowledge right now, and I don't have time to learn it right now. So I may never get there. Just like my logic analyzer. It definitely doesn't have memory to memory, specifically for sending pulse encoder. Yeah, I'm just interested to see how it gets access to the memory for the data. That must happen on the CPU side. There must be some type of buffer, right? Or something in the peripheral. How would that work? Because I can send a massive amount of data. Like, I'm not sure what the limit is, but it's pretty damn big. So somehow it's got to get that data in an efficient way to the peripheral. And it can't be buffering it, because then it's got to be bit banging it, right? So anyway, yeah, I don't know. Goddamned infernal time waster. Me? I'm not a time waster. Am I a time waster? I'm sorry. I'm just kidding. Okay. Thank you everyone for joining. It's been, it's been more enlightening for me than probably you. I probably learned more about my DS logic than you guys did. Thanks for the help from everyone that was pointing me in the right directions on that. I appreciate it. And yeah, I hope to get this, at least the driver side out, maybe this week or something, at least get it into my next version of my Tiny Pico firmware. Yeah, and is it the Thanksgiving for the Canucks? Okay, to everyone in Canada, happy Thanksgiving. Thank you all for joining. Been awesome. Big stream, 130 peak and current. That's pretty cool. I think that's my highest. Yay! And actually something I wanted to see. just very quickly, before I go, 1 second. Ah, damn. Thought I was going to crack the 7,000 subs today, but it didn't happen. Maybe tomorrow. Turkey. Yum. Now I'm hungry. I might go up the road and get something to eat. That'd be good. Anyway, thank you all. It's been great. I appreciate it. It's been an awesome chat today. I learnt a lot and I really, really appreciate it. Yeah. See you all. Wrong camera. Gosh, doing my head in. See you all next time. Where's the button?